Hey everyone, this is Manas Mishra. I'm a computer programmer, and today we're going to discuss the quick editorial and solutions for the problems of the recent Div 3 round. So as you can see, I was able to solve the first 7 problems, and for this contest, my final rank is exactly 300. It's a decent rank. I gave contest after 4 5 months, seriously. So yeah, I think it's a good rank, and I'll be bringing more contest discussions, maybe some live streams for lead code at Coder and Codeforces contests whenever I can give them. So you can subscribe to this channel, and I'll try to be consistent. And you can leave any feedback regarding any problem or any doubt you have or anything you want me to cover. I'll do that. So let's start with the first problem. In first problem, you're given three values. These are the tokens that Elias, Bob, and Charlie have. And what they're doing is pretty simple, that whoever has the most number of tokens will give one token to the person with the least amount of token in one round. That's what is happening. So if I show you how this works using an example, let's say A is 6, uh, B is 1, and C is 9. And let me order them into 1, 6, 9. It would be much better. So after first round, what you will have is 2, 6, 8. Because basically 9 gave one of their token to 1. And in second round, you will have 3, 6, 7. And third round, you will have 4, 6, 6. And now these two values are equal. So the game is finished and it took 3 rounds. And as you can see for this test case, the answer is also 3. What basically is having in this case that you are given 3 tokens, and if I rearrange them in increasing order, and let's say they are A1, A2, and A3, 3 values of tokens, then in each round, A3 moves by 1 step toward A2, and A1 also moves by 1 step towards A2. And whenever A1 is equal to A2 or A2 is equal to A3, any of these conditions fulfills, then the game ends. So how many rounds it will take A3 to reach A2? It is A3 minus A2. And how many rounds it will take for A1 to reach A2? That is A2 minus A1. And whichever one of these values is minimum will be your answer. So if you can see here, and by the way, A1, A2, A3 are these three values after sorting them. So for example, here, what we are going to do is we're going to take the minimum difference of A3 minus A2 and A2 minus A1. In this case, 3 minus 2 is 1, 2 minus 1 is 1. So see, the minimum of that is 1. That is the answer. Here, your A1 will be 1, A2 will be 4, and A3 will be 6. So 6 minus 4 is 2, and 1 minus 4 is 3. So the minimum of 2 and 3 is 2. That's why the answer is 2. Here, as you can see, the case we took, 9 minus 6 is 3, 1 minus 6 is 5, 1 is 5 away from 6, 9 is 3 away from 6, so hence 3 will be your answer. In this case, simply you just need to print the minimum of these two values and that will be your answer. Pretty straightforward problem for a div 3a, and that's how it should be. Now let us come to the problem B, which is much more interesting, and I would say it's a fairly good problem for a div 3v. In this problem, they are defining a compressed string. What is a compressed string? First of all, in a compressed string, you shrink a consecutive block of identical characters into a single character. So for example, wherever in your string, if you have something like A, you will shrink it into just a single A. Okay. So if I have triple A, BB, C, triple D, then this will become a single A, this will become a single B, this will become a single C, and this will become D. That's A, B, C, D. You can look up for a problem that is removing duplicates. It's a fairly, it's very interesting problem. It has a somewhat similar idea. You can look up into it. Now, so this is your compressed string. What is a compressed string? You need to shrink the contiguous block of identical character into a single character. Okay, now what they're saying is, you're given an original string s. You can delete exactly one character from second index to the n minus 1 index. It is one based indexing. And then you get a new string s dash. You cannot delete s1 or sn. You cannot delete the first or the last character. And this s dash, the string that you get after deleting that one character, this will be compressed. And now you want to find the minimum length of the compressed string. So first of all, what you do is, you have an s, you delete one character from it, and then you get s dash, and then you compress it, so you get fs. So now what will be the minimum length of such fs? That's what they are asking you to find out. So first of all, even if I'm given a normal string s, how do I find the length of its compressed string? How do I find this fs, the length of fs? How do I do that? So there's a fairly simple way to do this. What you can do is, let's say I have a, b, b, c, d, e. Now as you can see, you can, to create a compressed string, what you can do is take the first character of every block. Like in this block, this is your first character. Let's call it 1. Here, this is your first character. That's 2, 3, 4, and 5. And now if you put these together, you get your compressed string. And the length of this is 5. The way to implement this in code is that first character of a contiguous block, okay, its previous character will always be different from it. Like here, the previous character is same, but whatever characters I have marked in the string, their previous character cannot be same, because they are the starting point of a new contiguous block of character. So, and first character will always be the starting point. So any character s1 is always gonna be in the compressed string, and any si where si does not equal to si minus 1. So these are the set of characters that will be in your compressed string. Now I want the length of the compressed string. So I can say len is equal to 1 in starting, because s1 is always there. Now you can use a for loop from 2 to n, and what you need to do is, whenever your si is not equal to si minus 1, you can increase this length by plus 1, and at the end you will have the length of your compressed string. Okay, so that's how you find the length of the compressed string for a normal string. But you want to minimize this string after removing a character. So let's see what we can do about that. Now, first observation that we need to make is that, let's say if you have a block like this, okay, and there's string to the left of it and there's string to the right of it. If I remove this character, let's say I remove this character, now what does the string becomes? It becomes a, okay. Now initially in the compressed string, this whole block will cause a single character, that is a, that there will be in the compressed string. Here also this will result in a character a. So there's no reduction in the length of the compressed string at the end. Okay, let's take another example. For example, if your original string is b triple a c, okay, this is your string. The compressed string for this will be, take this b, take this a, take this c, b a c. If I remove any of these three characters, any one of these three characters, my resultant string is going to be b double ac, and the compressed string for this will also be bac. So as you can see, if the length, what insight we get from here, if the length of your contiguous block is greater than 1, and if you remove any single character from it, there are still characters left that will cause one character in the compressed string. So there's no point in removing such character which is a part of a contiguous block of length greater than 1. Okay, there's no benefit in doing that. Then what kind of character we should remove? Let's take an example of BAC. Okay, what happens here? If I remove this character, my string becomes BC, and to the left of it there might be something, and to the right of it there might be something. Now in this case my compressed string would be BAC. Okay, but in this case my compressed string would be BC. So as you can see, I am now able to reduce the length of the compressed string by 1. Why? Because this is just a single character. So if I remove this A, then there will be no A in the compressed string. So what is the condition that I got from here? The condition that I got from here, if there is a single, if there is a single character, right? It's not part of a block like triple A or double A. It's a single character. The single character is occurring somewhere. The size of the block is 1. Then if I delete that character, then I'm able to reduce the length of the compressed string by 1. What will be the condition for this? If this is a single character, then it will not be equal to the left side of it, and it will also not be equal to the right side of it. So Si does not equal to Si minus 1, and Si does not equal to Si plus 1. If this condition is true, if both of these conditions are true, then you can delete Si and the compressed string size will reduce by 1. There's one more case, the case of BAB. Okay, in this case what happens? In this case, if you remove this character, then the string becomes BB. Now see it very carefully. Here if you find the compressed string of this, there will be some compressed string for the left part, then this may or may not be taken. This will be taken, so it will be B, and this A will be there, and this B will be there. Okay, it could be something like BBB also. So in this case, like, it is going to be BAB at the end, right? So whatever there is to the side of it, it is going to be BAB, something here, something here. But here what happened? As you can see, A disappeared and both of these blocks became a single block. So rather than having two B's, now you will have a single B. So as you can see, the string length reduced by 2 rather than 1. One length reduced due to the single character that disappeared, and another length reduced. Another one reduction happened due to these two blocks becoming a single block. This block was causing 1B and this block was causing 1B. But now both of the block has become a single block. So it is just causing only 1B. So there's a reduction of an A and there's a reduction of B. So there is a reduction of 2. In this case, what is the condition? There should be a single character. So the condition is Si cannot be equal to Si minus 1 and Si can't be equal to Si plus 1. And there's one more condition, that Si minus 1 should be equal to Si plus 1. Now if these three conditions are met, then you get a reduction of minus 2. If only if this third condition is not met, then you get a reduction of minus 1. If none of these conditions are fulfilled, then you get a reduction. You don't get any reduction. So that's the whole idea of this problem. Again, if you have a character that is your Si, okay, if to the left of it the character is same, or to the right of it the character is same, then if you remove this, nothing happens. This character is still there. Okay, so you don't get any reduction. It's going to be zero change in the original compressed string. If you have a character that is A, here you have some character X, here you have some character Y, they are different, then at least this will disappear. So you get -1. If you have XAX kind of system, then this disappears and these two become equal. So rather than have two X's in your compressed string, you will have just one X. So one reduction due to this and one reduction due to this. There's a reduction of 2. So now what I'm going to do, I will iterate from index 2 to n minus 1. Okay, that will be my I. And for each SI, I will calculate this reduction score. It could be 0, 1 or 2. And I will, out of all of reduction scores for every SI, I will take the max. So whatever that max is, I will reduce that max from the original string's compression length. And that will be my answer. Let's take an example for this using a test case. So it would be much more clear to you. Let me create a test case of my own. So B, let's call it B double A B. Then there is A, C, and A. There is Y, C. Okay, let's call this is my string. Now let's go one by one. For this, see the right character. There are two set of conditions. Okay, there's Si does not equal to Si minus 1 and Si does not equal to Si plus 1. If this is true, then you get a reduction of -1. There's another set of condition that is Si. This condition should be fulfilled first of all. So it's the same thing. And Si does not equal to Si plus 1. And uh, Si minus 1 is equal to Si plus 1. If this is true, then you get a reduction of -2. So in this case, see Si is equal to Si plus 1. So both of these conditions failed. So the reduction score is going to be 0 for this. For this, again, this left part is same. So again, this is not going to work anyways. Like this will also have a reduction score of 0. Let's talk about this B. If you see this B, if I remove this B, then see this condition is fulfilled, right? This is not equal to the left side. This is also not equal to right side. But this condition is also fulfilled. A and A, they are equal. So this whole set of conditions are fulfilled. So -2 reduction I'll get. And I will show you this by an example. For the original string B, A, B, A, C by C. This is your compressed string. But let us remove this B. If I remove this B, then your string becomes B, A, A, okay, C by C. And the reduction compression string for this is B, A, C by C. This is length 5, this is length 7. So clearly there's a reduction of -2 for this. If you find the reduction score for this, it will be 1 because BC will be there at the end, but A won't be there. For this, the reduction score will be also 1. For this, if you try, the reduction score will always be -2. So the maximum reduction that I can get is of 2. And the original compression length is 7. I will reduce 2 by it and I get 5 as my answer. You can try this on some test case also. So this is the whole logic of this problem. I'll let you walk through the code of this problem also. So first of all, this res is the compression length of the original string. 1 for S1. S1 is always there. And I have written the code in zero-based indexing. So from 1 to n, from index 1 to n minus 1, you see if it is the start of a new contiguous block or not. This is the condition that is telling new character starting. So increase the compression length by 1. I'm adding a new character. So res will contain my original. And now the sub will store the maximum subtraction that I can get. And n sub is the subtraction for some SI. So see, if the first condition, the condition for something like BAC, like A is not equal to B, A is not equal to C, so I get a subtraction of 1. This plus plus is for because this A will get deleted. And here what I'm doing is, if si minus 1 is equal to si plus 1, like the adjacent characters are equal, but they are not equal to the mid character. So this is the uh, this same thing is actually written in a different way here. If you see it, if you compare, this, what this means a string like bab, and this means b and b, and a is different from b. So this is also something like bab. Okay, so then another plus plus. Okay, so basically both of these conditions are met, then you get a plus 2, and if only this condition is met, then you get a plus 1. Okay, and then you take the maximum subtraction out of all of these, and then you just for the case if like you don't get a negative value, because answer, it is just a good practice that your answer will always be at least 1, so take the max with 1, and the original compression length minus the max subtraction you can get, and you can just, in this problem you're given two binary strings, and you have to make a equal to b by performing either of these two operations, which is, if there's a substring 001, you can transform it into 100, basically reverse it, and vice versa. So 100 can be reversed to 001, and 001 can be reversed to 100. 00011 can also be reversed, and 110 can also be reversed. And now, using a finite number of operations, we need to tell for a given a and b if we can make a equal to b. So a lot of complexity and confusion of this problem is created intentionally by how these operations are defined. And let me actually simplify these operations for you, and then you will see how easy this problem is. Okay, first take this first operation. First operation is make 100 to 001, or 001 to 100. Now see very carefully that the position of this 00 does not change. The position of this 0 does not change, and this operation is actually swapping this 10 into 01. And here also this operation is just swapping this 01 into 10. So what information we derive from this? The information that we derive from this is that in some string, if there's some 10 and there's a 0 between them, I can swap these two characters. And in the same way, if I have 01 somewhere in string and there's a 0 in between, I can again swap these two characters. Okay, that's first observation. Now let's go to the second operation. That is 110 can be transformed into 011, or 011 can be transformed into 110. Now again, the position of this one do not change at all. It's same as it always was, and it is just the swapping of these two positions. It is the swapping of these two positions. 10 became 01 and 01 became 10. So now I realize that if I have 10 and there's a 1 in between, I can swap these two. If I have a 01 at a distance of, like they are at a distance of 2 from each other and there's a 1 in between, I can swap these. So if 10 is at a distance of 2, regardless of there is 0 or regardless of there is 1, I can always swap them. If I have 01 at a distance of 2, I can always swap them. Okay, for 0 also I can swap them, for 1 also I can swap them. So what I realize, I can swap any two characters si and si plus 2 if they are not equal. I can swap them. Okay, that's what we realize. And actually that's what you want to do. If si is equal to si plus 2, like this is also 0, this is also 0, why would you like to swap them? It accomplishes nothing. If my string is 1000 and if I'm swapping these two, my string will still be 1000. So that's not what I will want to do anyways. But now I can swap any two different characters that are at a distance of 2. See, rather than this complex terminology, now you have a very simple definition of operation. What is that definition? You can swap Si with Si plus 2 if Si does not equal to Si plus 2. That's it. That's the whole thing. Now there's two important observations from this. A very important observation from this is that the parity of I and I plus 2 will be same. If I is an even index, then I plus 2 will also be an even index. So what does that mean? If a 0 is at some even index, let's say 4, then it can go to 6, 8, 10, or it can go to 2, 0. But it can never go to 3, 5, 7, 9. How it will go? Because 4 can only travel like this or this, right? So odd indexes and even indexes are completely separated from each other. Okay, that's an observation that we derive from this. So we need to handle odd indexes and even indexes separately. Now let's see that. That's my first observation. So if let's take a test case where we will work. So for example, the seventh test case. Uh, yeah. So in this case, as you know, whatever operation I do, I cannot make a character go from even to odd indexes. So I'll create two strings from this. One is using only odd indexes. So 1, 0. I'm using these indexes. This, and this. So it is going to be 1, 0, 1, 0. And another string will be from even indexes. Whatever is left, that is 0, 1, 0. That is your, this is your odd A and this is your even A. Now same I will do for this. So I'll do it pretty quick. So that's going to be 0, 0 and 1, 1. And it's going to be odd B and even B. Okay. So the even B is going to be 0, 0, 1. Now see very carefully. This is in original string, this is index 1, 3, 5, 7. So these two can actually be swapped because they are at a distance of 2. Any two characters in this string that are adjacent are at the distance of 2 in this string. Same for this and this. So what I eventually want to do is I want to transform this string into this string, okay, and this string into this string. If I can do that by swapping adjacent characters here, then I can make this string equal to this string. Okay, so odd A and odd B and even A and even B. I should be able to do that. And any adjacent swap in odd A means a swap between these two positions, right? If I swap these two, then it means the swap between these two. If I hope you understand what I'm trying to say. Now, simply as you can see, and now let's take odd A, that is, let's call it OA, and odd B, that is OB. So to create this into this, what I can do, I can swap this. So it becomes 0, 1, 1, 0. And then I can swap 0 here and then here. So it becomes 0, 0, 1, 1. And I'm able to make this. And turns out, if the count of zeros, okay, the count of zeros and count of ones, okay, if they are same, in both strings, then you will always be able to create from this string, because you can rearrange by swapping adjacent characters. You can rearrange any permutation. You can create any permutation of 1, 0, 1, 0 by swapping elements. And so the count of characters must be same. The count of zeros and count of ones must be same in both strings. So what you're going to do is you're going to create these 4 strings. Okay, that's all we need to do. I need to know the count of 0 ones in this, in this, in this, in this, and in this. Now these two should have the same count of zeros and ones, and these should have the same count of zeros and ones. Like how many zeros are here? Same amount of zeros should be here. How many ones are here? Same amount of ones should be here. So then I can reshuffle these to make this. Okay, that's the whole logic of this problem. So the main observation of this problem was transformation of the given operation into this simple operation. Okay, after that you can just normally follow into this logic. Again, I'll say that you have string A, B, you separate into OA, OB, right? OA and my bad, OA and EA and OB and EB. So basically, OA is the string containing all the odd index characters, and EA is the string containing all the even index characters. Now, OA must be transformed into OB and EA must be transformed to EB. For that, these two should have same amount of zeros and 1, and these two should have same amount of zeros and 1. That's the whole point. Now let's go to the code for this problem. Code is very simple. I do not need to create these strings, but I just need to store the count of zeros and ones in both strings. So in odd A 0 is the count of zeros and odd A, and at the odd indexes of A, and basically odd A1 is the count of 1 at the uh, uh, odd indexes of it. By the way, you don't need to in hurry iterate both of them. Like if the two strings have same length and they have same number of zeros, then one will always be same. So you can just count the any one, zeros or ones. You can track for all four strings, and basically you can track these. There's a simple logic to just count, and odd A should be equal to odd B and even A should be equal to even B. If that's true, then the answer is yes. Otherwise, the answer is no. That's the whole logic for this. Now let's discuss the second part of this problem, that is the harder version. In this version, everything is same, the whole problem, but rather than yes or no, they are asking us how many number of operations you are gonna be needing to make A equal to B. So we will follow the same reasoning. Up till now, it's all the same reasoning, but this time it's not about yes or no, it's about how many operations we will need. So the total number of operations we will need are, like, we want to make odd A to odd B. Let's say this takes X operation, and odd and even A to even B, that takes Y operation. Then total of X plus Y will be my answer. Now the point is, first of all, the same thing follows again. The number of zeros and ones in both of them should be same. Then only I can make it equal. If that's not the case, then in this problem you need to return -1. Okay, so that follows simply. But if an answer is possible, then how do I find this thing? Like how many? Basically, the question now arises that if I have 1010 and I want to make 1100, so I know it is possible. I know I can shuffle it like this and it will become 100. In this case, it will take one operation, but they're asking like how many operations it would take for any case. So if now the problem has become that I have two strings, let's say X and Y, and let's call them A, B. So if I have two strings A and B, what they're asking is that given it is always possible to make B from A by adjacent swaps, how many swaps I would take. So that is a very standard problem. What you just need to do is, if I have, let's say, something like 10010, okay, this string, and I have 00011. If I just focus on placing the ones at the right position, okay, so if I'm able to, in this string, if I'm able to place this one and this one at their correct position, which is this and this, zeros will themselves be at their correct position because all the ones are matching to their corresponding ones. Zeros will themselves match. So I just need to focus on matching ones and at their corresponding position. And it is always optimal. It is always optimal to match the first one with the first one of the other string and the second one with the second one of the other string. So the algorithm for this is very simple. What you need to do, you need to list down all the indexes of ones in this string. What are the indexes of one in this string? 1 and 4. So 1 and 4. In this string, the indexes are 4 and 5. So there's the difference is of 3 and the difference is of 1. So total operation you're going to take as 3 plus 1, that is 4. Like I will need to do basically 3 swaps, 1, 2, 3 to reach here, right? And then I will need 1 swap to reach here. So total of 4 swaps I will need to transform this string into this string. Or I did it basically oppositely. What you would do is, let's say this is your A and this is your B. So you will basically need 4 swaps. Okay. So the algorithm is pretty simple. If you want to make A to B, what you need to do is list down all of the indexes of ones. And you can also do it for zeros also. It doesn't matter. List down all indexes of ones. Let's say they are let's call them I1, I2, I3. And here they are I1 dash, I2 dash, I3 dash. So your total cost, that total number of operation that A to B will require would be absolute difference of I1 dash minus I1 plus absolute difference of I2 dash minus I2 plus absolute difference of I3 dash minus I3. So this will be the cost. So we can create a cost function for any two strings A and B, and our answer, in our case, our answer would be cost OA OB and plus cost EA EB. Okay. So basically what we need to do, we need to make the odd part of the A equal to the odd part of B and even part of A equal to the even part of the B. And that will be our answer. Okay. If this part is not clear, like why this is optimal, let's discuss a bit more about that. For example, I have a string like 10010, and this is 11000. So why it is always optimal to match this to this and this to this? Because if you see, let's say I want to match this uh, one to this one, that will mean that I will cross while swapping. Like I will swap this to this and this to this. So this will become 00110 after 2 swaps. But now I'm swapping these 2 ones. Why? In order, because I want to make this one reach here. But swapping 2 ones accomplishes actually nothing. It will again be 0. Okay, this one came this side, but is there any point of it? I mean, they are indistinguishable. It is the same thing, right? So there is no point in making first one match with second or third or fourth one of the other string. So first one should always match with the first one of the other string. So that's why we list down all of the indexes I1, I2, I3 and I1 dash, I2 dash and I3 dash and take the differences of these. Okay, these many swaps I will need, whatever the distance is, and add them to get the cost. Okay, I think that then it would be clear. Now let's go to C2. So see, till this point the logic is same. If this odd A and odd B is same, then we will actually need to calculate. But if it is not same, then you return -1 like that from the C1. Okay. Now I have created this cost function. Okay. In cost function, what basically we are doing is we are having for any string A and B I have defined, the XA and XB are containing the indexes of 0. You can also do it for 1 and it will make no difference. You can also do it for 1 and it will be the same thing. Okay, so I push the indexes of 1 in XA and indexes of 1 in B into XB. And then your res starts from 0, and you just perform the elemental difference and sum them together to get your res and return. Whatever I explained in the slide there, it is the same thing written in code. And at the end, you create your odd strings and even strings, and at the end, your cost is just gonna be the cost of EA to EB and OA to OB, which is being calculated using this function. And that's the whole idea of this C2 problem. So let's move to the problem D, where you are given two arrays A and B, and basically BI is the sum of all of the elements in A that are smaller than AI. So basically BI is the sum of all AJ such that J is from 1 to N, and AJ is smaller than AI. Okay, so all the smaller elements in A that are smaller than AI, their sum is BI. So now then we are given B array, and we have to construct the array, the lexicographically smallest valid array for like if for which like B is the corresponding shadow array. Now lexicographically smallest, if you already do not know, is it basically prioritizes that on earlier positions smaller elements come. A is lexicograph A sequence A is lexicographically smallest than B, such that for some I, AI is less than BI, and AJ is equal to BJ for J less than I. So before the ith position, everything is same between A and B, and at this position AI happens to be smaller than BI. Then A is smaller than B lexicographically. If you don't know, you can look up for this board. Now we need to create lexicographically smallest. So what we will try to do is, if we are choosing the first element, we will try to absolutely minimize it. The later choices does not matter for now. At this moment, we just care about that our first element, that is A1, should be minimum. Okay, so now let's try to solve this problem. So let's take one example, that is 040414. 040414. Now here let's see an important observation. This is B2, this is B4. B2 is equal to B4, and I'm saying that implies A2 will also be equal to A4. Why is that so? So let's take the contradictory case. Let's say A4 is actually not equal to A2, it is greater than A2. If that's the case, then whatever is smaller than A2 is also smaller than A4. So now we'll recalculate the B4, right? So whatever is smaller than A2, that is B2. So that is also smaller than A4. So that will be in, but A2 is also smaller. So at least A2 will also be there. There might be more, but at least this much is there. So now this means that B4 is not equal to B2, because every value of A is greater than equal to 1. We know this from definition. So, but we started with the observation that B2 is equal to B4, right? So this can only be true when B4 is not equal to B2. Okay. And if you take this case also by symmetry, you will again come to the conclusion that B4 does not equal to B2. So that means that if they are equal, then their counterpart in A should also be equal. So what that makes us realize is that these two values A2 and A4 will be same, like some XX. These two values A1 and A2 will be same, some YY, and this will be some value Z. Okay, so same value in B means same value in A. Okay, that's first thing that we need to know. Now there's another observation that we need to make. Again, let's take the same case, 0 4 0 4 14. Now what I'm saying is that if here b1 and b2, if b1 is smaller than b2, then a1 is also smaller than a2. That's very simple thing, right? I don't think so I need to explain it, but still I would say that if a2 is equal to a1, that means b2 is equal to b1. We already proved it, right? So that cannot be the case. And if a2 is smaller than a1, that actually means that b2 will be smaller than b1. Like whatever is smaller than a2 will be in a1 also, but here we can clearly see that is not the case. So if you try to use some reasoning, then you will be able to come to the conclusion that if b1 is equal to b2, that means a1 is equal to a2, and b1 less than b2 means a1 less than a2. Okay, so whatever is the relation of comparison between values of b1, b2, or some bi or bj, that is the exact relation between ai and aj. That's the first thing that we need to know. Okay, pretty simple. Cool. Now this was about just relation. Now what is the next thing that we need to do? So that means that these two values are same, these two values are same, and this. Okay, now the point is that these two will have the smallest value of the array. Okay, then the next value will be this and the biggest value will be this according to the values of b. But what value we can put here, how we will find out that? So as you can see, this is going to be x, this is going to be, these are the values of a. Okay, this will be some y, this will be some y, this will be some g, and we know that x is less than y less than z. Okay, so what is smaller than y? There are two x's that are smaller than y. So what is smaller than y? We know there are two x's, so that is x plus x. So can we say 2x is equal to 4? And for this also you can say 2x is equal to 4. What does that mean? X is equal to 2. So now we know at this place we need to put 2 and this place we need to put 2. Okay, does that make sense? Cool. Now let's come here. What is smaller than z? There are two x's that are smaller than z, and there are two y's that are smaller than z. That is equal to 14. We know 2x will be equal to 8. My bad, 2x will be equal to 4. So 4 plus 2y is equal to 14. So 2y from here will be 10 and y will be equal to 5. So here I'll be putting 5. Now the interesting thing is that for this place, there's no bigger value than this. So I can put any value here that is just greater than this 5. So I'll put the smallest greater value, that will be 6. Okay, I cannot put here something like 3, right? Because that will now break the equation. 2 plus 3 is 5, 5 plus 2 7, 7 plus 3 is 10, but here we have 14. So if there was a another there was another value like 18, then I'll need to put 18. Then I'll need to put what here? 5. Then I'll need to basically uh, put whatever. Like if you have some value like 20 here, okay. So you already have 5, 5, 10, 14, 6. So then you will put 6 here. If you have 22 here, then you will put 8 here, right? That's how. So for the biggest value z, there will be no constraint, so you can put just whatever the last biggest value was plus 1 of that. So that's how you got 25256, which is the answer for this case. Now let's generalize this. What would be the actual algorithm? So it's pretty simple. What you need to do is you need to basically group indexes by their values and sort them in that order. In this case, like for 0, the indexes are 0 4 0 and 4 14. So basically 0 is at 1 and 3, 4 is at 2 and 4, and 14 is at 5th place. Now in this order only, because this will decide what will be put here, this will decide what will be put here, right? This gives us an equation, this gives us an equation, right? So you skip this first of all, because I don't know what will be put here right now. I come here, okay? So now I know this value is 4. So whatever I have till here, whatever indexes I have till here, their sum should be 4. How many indexes do I have? 2. So put 2 everywhere. 4 divided by 2, that is 2. Okay. Now I already have 4. Okay. I already have 4 with me. Like the sum 4 I already have. Now I have 2 more indexes. Okay. And the total sum here is becoming 14. So how much is left? 4 I already created from these indexes, 14 is the total I'm gonna having. So 10 more I need. How many indexes I have here? 2. Divide by 2, 5. So put 5 and 5 on these two indexes. Now the total I have created till this point was, let's say, 14. Okay. The total sum that I have till this point is, by putting 2 2 and 5 5, I have 14. Okay. And let's say for 14 also I had, let's say, 3 indexes, 5 6 7, and there was another one, like what we can have, we can have something like 41. Okay. So now 14 is, by these values, 14 I have already created. Now I have 3 more indexes, and the sum till this point is going to be this. So I need 27 more. So I'll put 999 here. Does that kind of make sense what I'm trying to do? So you basically create this arrangement where you put the values of B in increasing order, and list down their indexes, like how many indexes there are with each value, like this: 0, 4, 14, 41, like this. And how many values are here? Let's say you have 1 3, here you have 2 4, here you have 5 6 7, and let's say 8 you have here. Now you start from here simply. Okay. And by the way, 0 should always be there in the array, because for the smallest element, there's nothing smaller than it, right? Whatever the smallest element is, there's nothing smaller than it. So there will always be 0 at least once in your array. If 0 is not in your array at least once, what does that mean? That there's no answer possible. Okay. So in that case, like in this case, you will have your answer as -1. Okay. So 0 should always be there. Now again the same thing, what you need to do till this point, sum should be 4. How many indexes do I have? 2 indexes. So each index put 2 2. Cool. I'm doing it again. Till this point I should have sum 14. Okay. How much sum I have already created? See, this means the sum till this level, okay, is 14. This 4 means sum till this level is what? 4. Okay. I think that makes sense. So in this level, basically, the sum should be the difference of this, that is 10. So 5 5 you will get. In this level, the sum should be 27 in this level. So 9 9 you will get. Now, you know, when the problem will arise, let's say this is 42. Okay. So now sum in this level should be 28, but the index 5 6 7, they have values 14 14 14. That means their a5 a6 and a7 should be same. So all of them should have 28 by 3, but 28 by 3 is not an integer. What does that mean? 23 modulo 3 is 1. So there is a non-zero modulo remainder. That means in this case also the answer will be -1. That is another condition that we need to uh, be worried about. Now let us see the code for this. And so it's It's something like this. I'll go through it. First of all, this is the mapping that I have created. So this int, the key for this mapping is the sum, right? The sum bi and what indexes it will occurring on. Okay, this it is the same mapping. This mapping 0 occurs at 1 3, 4 occurs at 2 4, 14 occurs at this place. I'm storing that. Okay, an this vector a will contain our final answer. And now the thing is that 0 should be there in the array. So this condition is telling that if the first key, because map stores the keys in sorted order, so if the first key is not 0, then the answer is -1. Okay. Now I need to keep track of some things, which is what was the, like, how many indexes are there on the last level, what was the last e. Okay. So if for uh, for first key we do not do anything, then need is basically the sum of the need is basically this value. Like you had 0 4 14 41, so need is here this value 27. Okay, whatever your current x is basically the key, and the sum is storing the last key. If you can see here, your sum is the updating the last key. Okay, so need is basically that value. So if need becomes negative or 0, or whatever the last in the last is basically the number of indexes, the number of element in the last level. So if I'm at this key right now, last is containing this value. Okay, 3. So need is this 27 or 28, last is 3. So now 27 modulo 3 is 0, so it is fine. But 28 modulo 3 is not 0, so it is not fine. So last is this. If need becomes negative somehow, or it becomes 0, because 0 can't be there, and or its remainder with last is non-zero, then also the answer is -1. Otherwise we know what to put. Otherwise we need to put the need divided by last. Okay, and also one more thing we need to see. There can be one more case, which case is, let's say 0 4 14, and I put, let's say 23, and the same thing 1 3 2 4 5 6 7 and 8. So here what did we put? We put 2 2. Here we put here what we put 4 4, I think, right? Yeah. And here now let's calculate. So sum till this point should be 23. Sum till this point is 14. So here we should have sum 9. Okay. So we should put 3 3 3. But can you see where bi is 14? Can you put 3? So for where by was 4, you put 4. But when vi is 14, you're putting 3. That is violating our observation that if bi is less than bj, then ai should be less than aj. So if 4 is getting 4, then how can 14 get 3? Okay, that's not possible. So one thing I need to check more is that the last element that I put, my current element that I'm putting in A, it cannot be smaller or equal to that. It should be greater. If that is also not the case, then yeah, just go to those indexes and put that value, and just keep record of what was the last sum, what is your last size, and what is your last value that you put. Okay, so that's the whole code for this problem. Let's come to problem E. And actually this problem, I at least found it much easier to implement than problem D, and also a bit easier to solve also. So in this problem, you have an hidden array of strictly positive integers, and that you need to find basically, and B will be given to you. In B, the thing is that B1 is equal to A1, but after that, BI is basically AI minus AI minus 1. Okay, and after this you're getting a shuffled version of B. So let's take an example. So let's say if A is 1 3 5 7 2, then B for this will be B1 is just A1. Okay, then 3 minus 1 2, 5 minus 3 2, 7 minus 5 2, and 2 minus, that will be minus 5. And another characteristic is like that 1 plus 2 3, then 3 plus 2 5, then 5 plus 2 7, and 7 minus 5 is 2. Okay, so AI is basically the sum of B1 to BI. Okay, that is how also you can think about it. Okay, and BI is uh, AI minus AI minus 1, and B1 is equal to A1. Okay, now you don't get this original B array because then it will be pretty easier to find the A. But you get some kind of permutation of this, like 1 minus 5, then 1 and 2, and you can get something like this. Okay, and then you need to construct the lexicographically smallest original array A. Lexicographically smallest, we already discussed what it is. If it is impossible for any arrangement of B to produce an array strictly positive integer, then you can output, like if the answer does not exist, then you can put minus 1. Cool. Now the point is, the point here is that let's take a case, one for that there exists an answer. So let's say this one. There are few observations in this problem that you can make. So basically what we are trying to avoid in this is that first of all we want to put as smaller values before as we can. So like if if a choice of A1 is small but it makes A2 or A3 bigger, it doesn't matter. I want to make A1 as small as I can for it to be lexicographically smallest array. Okay. Now when the answer will not exist, whenever let's say I'm creating A1 to AN, and for some AI I'm not able to keep the things positive, this becomes negative or 0. That's not what I can do. I need to basically do it in a way that all of the values of A are positive. Now as we discussed, if you have B1 B2 B3 B4 up till Bn, we know that A1 is just that, A2 is B1 plus B2, A3 is B1 plus B2 plus B3. So we know that, like this is A1, the sum of this is A2, the sum of this is A3. Okay, sum of this is A4, right? We know that. So now the thing is, I need to basically, whatever B is given to me, I need to shuffle it in a way, I need to present it in a way such that these A1, A2, A3, the sequence that I get is lexicographically smallest, and sum of any prefix of this shuffled B array should not be negative or 0, because if it becomes negative or 0, then the answer does not exist. So see, however I shuffle it, the sum of the longest prefix, that is from B1 to Bn, like however I shuffle it, this will be An, right? If the sum of the whole array is negative, of the array B is negative or 0, then we know that An will always be negative or 0. So in that case, the answer won't exist. So as you can see, in whichever case the sum of the array is negative or 0, here the sum of the array is minus 1. So the answer is it does not exist. In this case also you can see the total sum will be I think it's gonna be 0, because these will cancel out, these will cancel out, and these will cancel out. So the total sum is 0. So An is gonna be 0. That's why the answer does not exist. Otherwise the answer will exist. Why otherwise the answer will exist? Because if you have a sequence, we're gonna prove something. If you have a sequence B1, B2, B3, B4 up to Bn, okay? And if you know that the sum of the whole thing, okay, is positive, if you know that the sum of the whole thing is positive, then you can always rearrange it always rearrange it in a way that the sum of any prefix will never be negative. That can always be done. Okay, it is always possible. So you can take like any example. So a fairly simple way would be that the sum of all of the values is positive. So whatever values are positive, I'll put them first and negative values later. That is always possible. Okay, in that way you will never encounter such thing. Like for example, you have 1 2 3 and you have minus 2 minus 2. So in this case this arrangement works because the prefix sum would be 1 3 6 uh, uh, 4 2. So this will be your array A and this will be your array B, but this is not the most optimal array because uh, turns out what you can do is you can arrange it like this also: 1, then you can go for 2, then you can go for minus 2, then you can go for 3, and then you can go for minus 2. In this case, this if this is your B, like this is a reshuffling of this B, then your prefix sum or A becomes basically A is the prefix sum of B. That's the thing. In a fancy way, A is just a prefix sum of B. So A becomes 1 3 1 4 2. And as you can see, this is lexicographically smaller than this array. So what kind of choice we should actually make? You know what we should actually do, that let's say I am having B1. What should I put at this place? I should place a number that is negative. Okay. But B1 plus whatever, let's say I put B2 here, it should be at least greater than 0. Okay. The sum of them should be greater than 0. So basically what can I put here? I can put any value that is bigger than B2 should be bigger than minus B1. So I can put anything that is bigger than what? Minus B1. So let's say I put something like, let's say I put some value B2 and it satisfies that condition. Now what I can put here? So the next, now this is my B1 plus B2. Now B1 plus B2 plus B3 should be greater than 0. So I should put anything that is greater than minus B1 plus B2. Okay. Same reasoning you can apply. What you should put at B4? You should put any value that is greater than minus of B1 plus B2 plus whatever you put at third place. And you can keep doing this. And if an answer exists, then this will work. Because at each step, you are making sure that you are taking that value which is bigger than this. And the way to implement this is simple. How you do this is, first of all, you take the input array B as an input. I have created a multi-set out of it. And now the simple thing is that if first value, the first value should be the upper bound on 0. So basically what this means is that first value should be positive, right? And if that gives you like end iterator, it means there's no value that is positive. The first value should be B1 should be positive, then only A1 will be positive. Then you can return -1. Otherwise, you can take that positive value and erase it. Now, after that, what's going to happen is I have pushed this first value into A. Now, after that, I need to push n-1 values more. What I will do is, what is my last value or the current sum? That is basically A dot back. So I'll take the minus of that and the upper bound of that. So I can, next value can be anything that is just greater enough than minus of current sum. Okay. And I want to create the lexicographically smallest, then that's why I will take the first value that is just great enough. So that's why I'm taking upper bound. And if upper bound does not exist, right? So there's no, let's say if I am at 3 So I need a value that is just greater than -3, but there's no value that is greater than -3. That means whatever I'll put, it will make the next element negative. So I'll do -1. Otherwise, I will just use that value, I'll put it, and I'll put cur. Cur is my current prefix sum, like the last value that I put in A. And then I'll put cur plus x, and then I'll just repeat it. And that's the whole code for this problem. So the next problem that we are discussing is problem F. In this problem, there are two arrays of even integer size n, and this even thing is going to be a very important part of this problem. And these are non-negative integers. Now, the operation that you can perform on this array A is defined in this way. So you can choose any index I, and for all other indexes not equal to I, you have to replace that index, its value, with the value XOR AI, and of course AI remains unchanged. So if we try to understand about the operation very simply, then if you have, let's say, a1, a2, a3, a4, so if I perform this operation for I is equal to 2, then the array will become a1 XOR a2, a2, a3 XOR a2, and a4 XOR a2. This is the operation that they have provided. Now they are saying that you need to output yes or no, like if you using this operation, can you transform this array A into array B or not? This is the whole problem. Let's say a1, a2, a3, a4, a5, and now let's say if I want to swap a2 and a4. So see what I'm gonna do. I'm gonna perform first operation on I is equal to 2. So the array becomes a1 XOR a2, a2, a2 XOR a3, a2 XOR a4, and a2 XOR a5. Cool. Now I'll do this operation on 4. So doing this operation on 4, that will make it a1 XOR a4, then a4, then a4 XOR a3, a2 XOR a4, and a4 XOR a5. Now let us do this operation again on I is equal to 2. Now what will happen? This will become a1, this will become a4, this will become a3, this will become a2, and this will become a5. Can you see that by doing operations 2 4 2, I'm able to swap a2 and a4, and by symmetry, if I do operations 4 2 4 in this order, then also a2 and a4 will be swapped. So what does this tell me? If I do operations in order, first for I do for AI, then I do on AJ, and then I do again on AI, like whatever AI is at that moment, then AI and AJ are swapped. Okay, does that make sense? So if I say op I, performing operation on I, then performing operation on J, and then again performing operation on I, this is equivalent to swap AI AJ. And I have supply to unlimited amount of operations and nothing changes. So now basically what means is that on my array A, I can swap any two elements. What does that mean? I can create any permutation of this array. So the very important point is that if A and B are permutation of each other, like if I reshuffle A and I can able to make B, then the answer is always yes, because I know how to do it. Like I know how to simulate a swap using these operations. So that's why this third case, if you can see, what they eventually did was they turned 1 to 4 it into 8 4 to 1, and that is possible by just swapping a lot of elements until, swapping a lot of elements here, like swapping 1 with 8 and 2 with 4, you will get this. So in this case, for 1 2 4 8 and 8 4 2 1, what will be my operations? My operations will be, first of all, I will do operation on 1, then I'll do operation on 4, and then I'll do operation on 1. So then 8 and 1 will be swapped, and then I'll do operation on 2 3 2. That will swap these two. Okay, so first observation is that if A and B are permutations of each other, okay, then answer is always yes. So first observation is pretty clear. If A and B are permutations of each other, answer is yes, because we know a way by which you can reshuffle A into B. That's we know by swapping elements. Now let's come to another pattern. Let's say A1, A2, A3, A4. Let's say I did operation on A1, so it becomes A1, A1s or A2, A1s or A3, and A1s or A4. If I do operation on 2, then it becomes A2, A1s or A2, and A2s or A3, and A2s or A4. If I do operations on, let's say I is equal to 4, then it becomes A4, A4 XOR A1, A4 XOR A3, and A4 XOR A2. So can you see the pattern here? The pattern is one place, one index of the array has an original value out of A1 to AN, some value, okay? And the all other indexes have values that are combination of that single value, and XOR with other values of the array. So if at this place I have A4, then here I have A4s or A1, here I have A4s or A3, here I have A4s or A2. Okay, XOR of this value, this single element, with the remaining values of the array. This is the pattern. If I need to generalize this pattern, then at one index I'll have some AJ, okay, and at any other place I have something like AJ XOR AI, okay, where I does not equal to J, okay, at these n minus 1 places. And of course, this I will be like all of the I will be covered except 4. Like A1 will also come, A3 will also come, A2 will also come. They will always come one by one by one. This is the pattern. And now, as we know, we can always shuffle these patterns. So this AJ does not need to be here only. This A4 does not need to be here only. I can also create this A4s or A1, then A4 is here, then A4s or A2 is here, and then A4s or A3 is here. I can create an array like this where A3 is, let's say, my alone element, A3 or A6 is here, A3 XOR A5 is here, A3 XOR A2 is here, and A4 A3 XOR A1 is here. Like all of these, you can basically, yeah, A3 XOR A4 is left, A3 XOR A4. The pattern, so this is my pattern. Now let's say one of these pattern, what I wanted to do, I wanted to match to B3, B4, B5, B6. Let's say that was my B array that I want to match to. So let's say one part of this pattern matched with this, where A4 is my alone element, and here let's say I got A4 XOR A2, here I got A4 XOR A1, here I got A4 XOR A6. Here I got A4 XOR A5, and here I got A4 XOR A3. As we know, we can permute, so the single element need not to be at this place only, it can be at any place. So now we know that these elements are equal, right? They are equal. So what happens next? I know that XOR of this A4 XOR A2, A4 XOR A2 is equal to B1. That's I know. So can I say that A2 XOR B1 is equal to A4? Can I say that? Can I say that? I can say that. For this, can I say A1 XOR B2 is equal to A4? For this, can I say A6 XOR B4 is equal to A4? Can I say A5 XOR B5 is equal to A4? And for this, can I say A3 XOR B6 is equal to A4? Right? So can I have these 5 conclusions if this arrangement is equal to my B array? Okay, I can say that. Now if you, and I can also say A4 XOR B3 is equal to 0, because they are same. They need to be, A4 is equal to B3, so A4 XOR B3 is equal to 0. Now if you, all of these equations, if you XOR their left hand side and if you XOR their right hand side, so on the right hand side I'll always have n minus 1 numbers of A4, and that will always be odd, so I'll get A4 on the right side. I am doing XOR, I'm doing like you do addition, like you add two equations, I'm XORing two equations here. And on the right side, as you can see, I'm having A1 A2, I'm having A3, okay, and I'm having A4, I'm having A5, and I'm having A6. So I'm having A1 XOR A2 XOR A3 XOR A4 XOR A5 XOR A6. And am I having B1? I'm having B2. I'm having B3 will be somewhere also, I think. There's B3, there's B4, there's B5, and there's B6. So I'm having B1, I'm having XOR B2 till B6. So if this arrangement is working, what is this? What is this I have written? It is the XOR of all of the elements, all 8 elements, all 8 elements here, all 12 elements here. It is equal to what? A4. What is A4? A4 is your special element that will be alone. So that tells me that if I want to look for the alone element, the element that will be alone in the end in my A array, you just need to XOR everything that is given to you in the test case. Okay, and whatever that comes out to be will be your alone element. Okay, so what I will do, I will XOR everything that is in array and B, and I'll get a value, let's say XR. So first of all, this XR should belong to the array A. If that's not the case, then your answer is already no. Okay, that's first check you need to make. Now what you need to do, this XR is your special element AI. Okay, so what needs to happen now is that all other, let's say this was A3, okay, so all other elements A1, A2, A4, A5, A6, and here you have B1, B2, and let's say it was equal to B4, so B4 is out, B3, B5, B6. So now what should happen is that if I do A3s or A1, it should be able to cancel one value from here. Then if I do A3s or A2, then it should be able to cancel one value from here. And so basically A3s or let's say A4, it should, let's, if it gives B1, then what I will just do is A3s or A4 I will put in front of B1. That's what I'll do. So basically there should be an element wise mapping among these two arrays such that A3s or this gives me this. Okay, that's the whole code. That's the whole logic of this problem. I'll go through the code pretty quick. It's a bit complicated idea to grasp, but if you will try to do it on your own, you might be able to get it. So I'll explain again in code also. So first of all, I have both of my arrays. I have created multi-sets of these arrays because there can be duplicates, and we will see why multi-sets are required here. Now, this is the uh, this is basically I'm zoring everything into this XR. So XR is your special element, which we need to find out, which will be alone. So if AA and BB, AA is multiset of A, BB is multiset of B. If they are same, that means they are permutation of each other. So the answer is always possible, which we discussed earlier. Now the thing is that if XR, this spatial element is not present in A, this means it is not present in A, then how I will create this element? It should be present, it should be some AI, right? So that way answer will be no. And if it is not present in B, it is only present in A, then how I will get that corresponding element? So that way also answer will be no. If it is present in both of them, then I will erase, like there's a matching between these two. Now for everything else in your multiset, now everything else in your multiset, like in this case, see 7 and 7 will match. And now what you can do, you will do XOR of 7 XOR 1, that will give you 6. So 1 and 6 are matched. If you do 7 XOR 2, you will get 5. So 2 and 5 are matched. Then you will do 7 XOR 4, you will get 3. So 4 and 3 are matched. So 7 matches to 7, 1 matches to 6, 2 matches to 5, and 4 matches to 3. So what you need to do is you will find that your special element XOR, the current element of A, is it existing on B or not? If it is existing in B, then you can erase it. Okay, that's how I do. And now if at the end there are some elements remaining in B, that means there was not perfect matching. If there wasn't a perfect matching, then the answer is no. Otherwise the answer is yes. That was the whole code for this problem.